So, as Eric mentioned, we wanted to use this space a little bit more interactively. It's one of the things we've tried to do year after year in this event. As you can see, the day gets gradually more convivial as we go, and I like that. There's some very dry events that I've hosted where it's just PowerPoint slide after PowerPoint slide, and I think as most of the speakers and panelists will testify, I pretty much banned slides for any of the panelists, and one or two got through. I'm looking at Phil. But we decided to make some use of this space. It's an open mic session. Anyone who can play the guitar who brought one with them is welcome, but we're not really planning to do that. We're going to stay on topic. So what I thought we'd do, rather than just go around the room and ask people to just introduce themselves, which I'm going to start by doing, but rather than just do that, I thought we'd actually get some questions in the box, and we're just going to pick and mix and match questions with people and then fire them back. So one more time, let's just go around the room. Quick introduction, name, your role. I think we'll add to it what brought you here today. What are the key things you were hoping to get out of today? So if we could start on the left and work around again, that would be great. So, Andrew.
Again, Andrew Robinson. I'm with Jetstream. I'm Senior Sales Consultant. Why am I here today? I'm here to hear about the ecosystem's infrastructure with CDNs and where is it going in the next 12 to 24 months. Thank you, Don.
Andreas Remarketing, hello, head of broadcast technology for Thomson Reuters. Main focus of interest is because we are doing business to corporate, which means corporates are always 5 to 10 years behind where the consumers are. So for us, it's a good sneak peek what's going to come for us.
I'm Simon Bull, Global Head of Operations and Multimedia Delivery at Thomson Reuters. I'm here today because I thought, well, I'll come a day early and see what I can find. And I actually had a very good session this morning, a workshop.
Bob Martin from SSVC, basically trying to find out about infrastructure and providing our services or using this type of technology.
Alexander Belli, Senior Technical Evangelist for our social media platform. And I'm here, I was on the panel earlier, and I'll be delivering the last session of the day, so those are here to speak.
Eric, you know, so we'll go over to Yaroslav.
I'm Yaroslav Gradevsky, I'm CEO of Cdn Video, CDN, and I'm here to get more new ideas for further business development and share my own and share our ideas about CDN and what we can do for CDN market.
I'm from Dmitry, Chief Engineer of Novosti, Russian Information Agency, and I know you study more you about CDN content platform.
I'm Jeff Davis from Sony, and I design TV stations and things like that. And basically the reason I came along today in the next couple of days is to think about how we add some value when the poor souls have to feed the content into the chaos that is virtually free over Second Street and various other jolly places.
I'm Stephen Jones, I'm here from Wrightstead today. I was invited to speak earlier. I'm passionate about developing and delivering really good solutions for companies who utilize video and send it to the users. So I'm really interested in finding out what's happening with platforms, and having moved out of the CDN companies into being a CDN customer, I can find a little bit about what
4 times today. I ran our code shop. We have a delivery platform, and what I was hoping to look into maybe our people's requirements and expectations of the delivery and to the layouts.
Olivier Noël from M6. I'm architect of the video platform, and today my main I'm here to hear about policy issue and how can we deploy and implement new DRM system in our platform for example Apple systems, etc.
Hello, my name is Phil Wiegord. I'm from the Austrian Broadcasting Corporation. We have something similar in Austria like the Apple, which is called Prefetching, which are not too built up the last 4 years. A topic I would be interested in is commercials, like commercials in form of pre-rolls and post-rolls demos. I'm wondering if CDNs can offer a solution which copes to deal with all kinds of platforms. So pre-rolls work on iPhone, Android, Samsung, Flash, and so on.
Hello, my name is Mirko Rekek. I'm from Media Interactive, a small company. We are mostly interested in bringing together content production and distribution. So combining both this field and trying to automate workflows for content delivery. So I'm here to get some new information about delivering video to all kinds of platforms.
Hi, I'm Roman Vucic, also from Media Interactive. I'm more like a graphic designer, but I like to think and know all the latest news about technology.
I'm Frank Rex, also from Slovenia. Besides what my colleagues want to know, I also would like to know, is OTT ready for prime time and to make money?
Hi, I'm Phil Hager. I kind of like two things in life, technology and also money. Now I sit in that gap in between those two people, in sort of those two areas. So my clients usually come to me and say, how should we do this? How should we launch online television? Should we go with Brightco? Should we go with Uyard? What about Amazon Web Services? So attending events like this is very useful for me because not only can I talk to people who are doing similar things, but I can also get to hear where the industry is going, be it Dash, interoperability of DRMs, and all that sort of thing. So thank you very much.
I'm Sjoerd Vogt, and I'm one of the organizers of this event, and I'm not here to play the guitar. Oh. So I'm Tristan, the doc from the media friends. I'm here to give my vision on infrastructure and also to understand what's hot and what everybody's thinking about CDN infrastructure.
Hi, Steve from Ideas. What we do is build bespoke media workflows, so here to see what other people are doing in that field.
I feel like I should ask the AV guys as well, because they're the only people with cameras and never video instructions. So feel free to introduce yourself. I'd love to point the camera. Okay, he gets away with it. And Dick Hayes is hiding behind the pillar there. He's information today. Okay, so what we've done is we've collected some questions and names, and I've asked Eric to have a little pick through them. What have you done? Sorted them out to the best ones?
I hope so.
Okay, cool. We're just going to pick some at random. So I've got a question here. Does the microphone help? No. Yeah? Okay, we'll stick with the microphone, I feel. Again, it's back to the Terry Wogan comments. But okay, so question here from Steve Miller-Jones, who is sitting over there. So will the ability to skip adverts like on YouTube force a new monetization strategy on content rights owners and producers? So Steve, let's start with your response to your own question. And then I'm going to get Eric to pick a name at random to victimise with the same question.
So the question comes from this comment from the VP of Content Sales at YouTube at MIPCOM last week, who stated in his keynote that YouTube in the US, on a monthly basis, earn as much money from their skippable ads as cable TV did in the US.
Okay, this is what, generally?
Generally, that's what he said. So you can skip the ads unless you want to watch them.
perspective and the CDN perspective, a lot of people who are attracted to linear TV have moved over towards the over-the-top IPTV, particularly for the reason that Steve's pointed out, to skip the ad. If I'm paying, I don't want to have my film interrupted in the middle. And then, of course, if I go across to the OTT platform, I want a good quality service equivalent to linear television. So in terms of dropping the adverts or monetizing it in a different perspective, that is definitely one of the cases that's going to happen, and it's going to be a big driver to encouraging more OTT, IPTV services run from CDN platforms.
Cool. I think that plays in very interestingly to your questions in the corner about whether OTT was ready for prime time, and to some extent I think control of advertising in that space is going to make quite a difference. Okay, let's do the next one. Question from Maria. So in an ideal world, what technologies would you use to deliver a video on demand service? Focus on security and file delivery. So Maria, let's hear your answer to your own question first, and then we'll pick a name from the hat to victimize.
In an ideal world, I think I would want less security than what we've got. I think the security is useful, but only unless it doesn't stop the user experience. And I think right now it's hurting the consumer experience. So I think that there's something that needs to be done as far as balance. As far as the file delivery piece, one of the things I don't like is adaptive streaming, because I don't like the idea that I can't control the consumer's experience of the quality in which they're receiving something, because it can drop in quality. So I prefer things personally that don't involve that. And I also like, having worked with a few different technologies, I really like things like the MPEG transport stream structure, because you can easily deal with things like accessibility and adding in audio tracks and stuff like that, which I don't think the MPEG-4 deals particularly nicely with, and I'm hoping taking the common file format and maybe Dash do better.
That's really interesting. I think that I've never heard that argument about adaptive bitrate before. I think it's very interesting. Okay, let's pick a name at random. Phil, let's hear your comments on that.
So, in opposition to you, in your second point, I really like adaptive streaming because I can't control what my daughters are doing on the internet. And I live in a village, which means that I don't have a very fast connection. And both of them, like when my young daughter's in the bath upstairs with a MacBook Air, propped on the toilet watching the X Factor. Yes, I know it's dangerous to do that. Watch the X Factor, when she's doing that, if I start to watch Netflix or something downstairs, she immediately screams at me, "Dad, the internet's gone rubbish." So if you were able to control the quality that I was getting on a set-top box downstairs, she'd be absolutely furious upstairs. Instead of adaptive streaming, all of our qualities degrade for a while. And then come back again, and that's kind of okay in a democratic family. In terms of the security side, listening to the panel that I had the privilege of chairing this morning, I used to be quite into DRM because I sold it. I don't really think it's really brilliant these days because I've had more problems, and I think people operating DRM have a lot of support ticket issues of various things needing to be cleaned out, uninstalled, or re-individualized on their devices. I'm very taken with the idea, if it could work, that watermarking at the time of transaction is actually a really good thing. From experiences I mentioned this morning, it scared me with daylight. I think my ID is somehow stored in the video file. There's no way I'm going to let that go torrenting or Bluetooth around.
Brilliant, Phil. Okay, next question, please, Eric. This is from John Welsh. What do the panel think of the new platform as a service from Oracle? John, where are you? Hold on. There, John, sorry. That's a good question. Let's hear your answer to that.
I'm actually not really sure. One of my developers left and went to work for it. It's others as a UI designer. And it just seems to be, that will be part of this way
I'll throw in a comment there. I had a look at that Oracle offering, and it's kind of interesting that a cloud is sold as some tin that Oracle turn up and install on your infrastructure and manage for you and run your applications for. It sounds just like outsourcing to me, but in-house. Yeah, rain, puddles.
Fog at the very least.
Okay, Alex, have you got any thoughts on Oracle's?
Do you know what? Christ, I haven't got a clue. I'll answer next.
Okay, cool. Okay, let's find out what question you're going to get victimized with. So, how disruptive is Google's Widevine strategy? From yourself.
Very dismissive of Marlin, and he said as well, effectively Google also quite squaring up to Microsoft really for a real clash of the titans there. There's only one DRM standing in the next couple of years. It's not unknown for Google to try something a little bit disruptive in any marketplace. My question is, we've not really heard much about
That's one for the list next year, actually. Okay, let's pick someone at random. Andreas, know anything about Widevine?
Please, nothing I can disclose. Let's call it that one.
I mean, I think a general.
Skip on that one.
I think a general comment on DRM is I think it's. I'm totally with Phil. I think watermarking has got to be the future, because until someone can stop me pointing a camera at a screen, DRM is hackable. And if DRM's principal responsibility is to manage rights, not revenue, then I think DRM is just a convenient way for the content providers to point liability at the moment. I think digital revenue management would be a much better use of the acronym. That's my own opinion on it. So. Anyone have any particularly strong views on Widevine? Okay, it's obviously very successful. Let's move on. So from Addy, is Quaz something really maintainable and chargeable in the mobile network scenario? So where's Addy? Out there. So.
My answer is basically no. We have a lot of knowledge of mobile networks. And once you're in the peak hour, you're walking down Manhattan or downtown London, everybody's checking their email. I was in New York a few months ago, and I couldn't even get Google Maps to work on a Verizon phone in the middle of Manhattan. I couldn't find my way where I was going. So it's all nice stories about quality of service, and you can charge it. You can have a turbo button, all kinds of nice stories. But in the end, if the cell is loaded and the network is loaded, there's nothing you can do. And you can differentiate between the users, but you have so many users that you won't even be able to get signal with the tower. You can't get the signal to work, so how are you going to get the video to work?
Rob's not here. Rob from Nokia's gone, hasn't he? It's a shame. That would be a good one to point at Rob. So let's pick somebody at random. Oh, somebody's folded their note up. They've obviously done that. That's you. What's going on? Let's pick someone else. Yaroslav, any comments on cause and operator CDNs for mobiles?
In mobile or?
It was particularly focused on mobile, his questions. So.
Pretty agree with pretty agree that it looks like quality of service can be guaranteed, but it's not in many cases, because sometimes the
Yeah, no, I think back to the, I wrote a comment for the magazine on the outage that they had with the mobile networks around one of the cycling events in the Olympics, and there was a message that went out from the IOC that they'd be very pleased if everyone could stop tweeting, with taking absolutely no notice of the fact that there were probably over 200 cell muxes, cellular link aggregators, all of them pumping 1.4 meg each up onto the local cell towers. I mean, in comparison, I really don't think the Twitter data was having any effect at all. So I'm not quite sure what those mobile networks are offering. But Simon, how long will WMV and Windows Media and Flash last as a supported format by CDNs? That's a great question. Simon, what's your thoughts?
Not very long. I think Windows Media, less so. I think there's a lot of investment happening in Flash, so I think it'll be with us for some time to come. But we're already hearing the murmurs on the CDNs and the CDN as well, that it's something they're beginning to consider legacy.
And it's close to your heart because you still deliver a lot of it.
Well, we deliver to the corporate enterprise, so Windows Media is still something that we deliver. In fact, we have certain scenarios where we prioritize, we default to Windows Media, specifically because of the enterprise component.
Any thoughts on Windows Media and Flash as their longevity?
I don't think you can get rid of them so quickly because of the long tail, especially many sites and a lot of stuff people don't like to talk about, but there's, and the traffic in the internet is half YouTube, half porn. And porn industry works for rules, but it makes on itself. So, and they, I think a couple years ago, they still were using VP6 and nobody else was still using that codec. They're not
We are. We're still using VP6 too.
No other websites are using VP6. So there's a long tail in the internet that it's going to be hard to get rid of for CDNs, I think.
I'm slightly confused. We've overrun on the open mic session. I'd love to carry on. Actually, I've still got a box full of questions, and we could keep going. But we have got to 4 o'clock. So at this point, really, it's appropriate to hand us over to Alex to give us a breakdown and a presentation about MPEG DASH. But I'm hoping it'll stay interactive. So do feed into what Alex says, and I'm going to hand you the microphone. Thank you, guys. Thanks to everyone.
Shall I take it back here, I suppose? Or let me at least load up the session. Great. I think you can actually probably all hear me anyway, but if you can't, I'll switch over to the handheld microphone. So I guess it's now the third time I'm introducing myself. So I'm Alex Zambelli. I'm Senior Technical Evangelist for the Microsoft Media Platform. And so what we're going to talk about today is Dash. And I'm going to frame the discussion. I'm going to start off by basically talking about the history of Dash for probably about the first half of the session, just to explain how we got here, why did we get here. And then we're going to talk about what does Dash mean for CDNs in terms of delivery, and how CDNs can actually get themselves ready for Dash. And I'll talk a little bit also about Dash in the context of Windows Azure Media Services and what we're planning to do there in terms of roadmap. So we'll start off with the history of Dash. If you remember the 90s, so internet streaming really was pioneered in the 90s. That was when companies started experimenting with delivery of media over the internet. And does anybody here remember which company did the first live streaming event and what year it was? Any guesses? 94? Too early, but you're close. What was it?
it was, to the best of my knowledge, it was 95, and it was Progressive Networks, which then later became Real Networks. But it was, yeah, it was around that same period. So it was 94, 95 was when first companies started playing around with it. Then it was, of course, first audio streaming, then video streaming came later. And there was many proprietary protocols that emerged first, such as the Real Networks protocol was the first one, the PNA that was carried over the Real Data Transport protocol. And then there was a process to get some of these things standardized. So we then got RTSP. That standardization took place from 96 to 98. So 1998 was when we got RTSP standardized. And there was also, of course, other proprietary technologies for streaming at the time by Microsoft and by Adobe. And many of those are still in use today. So there's still some RTSP usage, for example, from real Helix servers. And then, of course, there's still Windows Media Streaming. There's still RTMP streaming. So we still use some of these technologies even today. And then, of course, there's always been HTTP progressive download for just delivery of files from web servers, which then became even more relevant once HTTP 1.1 enabled by range requests and the ability to actually just request pieces of the file rather than the whole file. By the way, if you remember all of these protocols, you've been doing this for a very long time. So why did we suddenly start doing adaptive streaming? How did that all come about? Well, traditional streaming was, like I said, really came about in the second half of the 90s. And so just to give you an example, in 1998, when RTSP was standardized, there was about 100 million internet users in the world. Today, there's about 2.5 billion internet users in the world. So the internet, in terms of audience size, has grown about 25 times since 1998. And that has changed, of course, that has had an impact on scalability of streaming. The other thing was that at the time when RTSP was standardized, there was essentially no CDNs yet. The first CDN, I think, might have been actually 98 or 99. So content delivery networks did not exist as such. So the problem there is that, A, the traditional streaming was just not designed to scale to the internet audience that we have today, and it was not designed really to fit into this infrastructure of the internet that we have today, which is very largely HTTP based. The idea behind things like RTSP was that, oh, well, let's design a new media protocol for delivery of media because we think this is how it's going to be done. And then the idea was like, okay, all you CDNs, once they were actually invented, you guys go now deploy all these RTSP servers or RTMP servers and Windows Media servers to your edge, and it's all going to work. But the reality of it was that really what CDNs were deploying mostly, probably about 95% and more, was web caches, HTTP caches. And then the final part was that even though we had CDNs in place, last mile delivery was always an issue. So with traditional streaming, even if you're trying to deliver, let's say, just like 1 megabit of streaming media, getting that consistently to a large number of users was very, very difficult. You had to have a lot of proxies deployed to the media proxies deployed to the actual edge, and so that last mile was always a problem. So at that point we said, okay, if the internet is really made of web caches predominantly, then let's actually figure out a way to deliver media in a way that's actually going to be adaptable and to the way the internet is actually built. So rather than try to build media protocols that we want the internet to bend to, let's actually bend to what the internet is today. And so in 2007, one of the first companies that came out with an adaptive streaming HTTP-based delivery method was Move Networks. They referred to their technology as Streamlets. That was basically a fragmented way of delivering media where they would encode media, break it up into small fragments, and then deliver those fragments over the wire. And then on the client side, they would adapt, they would pick a different bit rates depending on the network conditions, and that was adaptive streaming. In 2008, Microsoft came out with Smooth Streaming. That was in late 2008. A little bit earlier, I think this summer of 2008 was actually a really big event in terms of the timeline of adaptive streaming, and that was when Netflix came out with their Watch Instantly feature. And that was something that they built as a proprietary technology from ground up, and then plugged it into the Silverlight media stream source interface. And that was, to this day, is probably actually still the largest adaptive streaming deployment in the world. 2009 was when we got Apple HTTP live streaming, or HLS, and that was primarily for delivery to their mobile devices. And then in 2010 was when Adobe came out with their HTTP dynamic streaming to basically complement the existing dynamic streaming feature that they have for RTMP. So that's a timeline. And somebody earlier today mentioned that, for example, YouTube has also now embraced adaptive streaming. They have their own sort of proprietary implementation, which looks like it's HLS. We're not quite sure if it is or it isn't entirely HLS, but it's certainly very similar to it. And now they're beginning to actually use that for delivery of live streaming events. So for example, the NBC Olympics event this summer, that was delivered by YouTube using their adaptive streaming. The Felix Baumgartner jump from the stratosphere yesterday, that was delivered using their adaptive streaming. So this has now become a de facto way of delivering both large-scale live events and premium movie content, video content. So I mentioned that in 2008 we came out with smooth streaming. And when we were designing smooth streaming, we made two design choices that ended up sort of setting off this whole avalanche. One was to use a feature of the MPEG-4 file format, the ISO base media file format, that allowed us to essentially distribute, or I should say divide up the actual video and audio within the file into fragments that made it easier then later to split them up on the fly for delivery over the wire. And so this became known as fragmented MP4. And the other decision that we made was to use XML as the basis for the manifest that was used to actually describe the media, how the fragments were organized, how many bit rates there were, and so on and so forth. Next year, 2009, we released a spec called PIF, the Protected Interoperable File Format specification. And that was just a standardized version of the file format that we had designed for smooth streaming. And one of the things that was a part of that spec was also a description of how to essentially incorporate playwright encryption into the whole smooth streaming file format. So DCE that same year started work on what they refer to as the common file format, or the Ultraviolet file format. And after some discussions, they decided that as a basis for the new file format, the common file format, they're going to use PIF. And so it was sort of this avalanche that started out with us saying, oh, we're going to use fragmented MP4 for smooth, that became then PIF, and then PIF inspired CFF. And so as a result, the DEC common file format now uses the fragmented MP4 as their file format, and has also a feature that allows multiple DRM schemes to be used together with AES encryption, and that's known as common encryption. Around the same time, 2009, was when 3GPP started looking at, okay, we got all these now adaptive bitrate technologies in the marketplace. At that point, HLS was already out, smooth streaming was already out, Move Networks was doing their thing, Netflix was doing their thing. And so 3GPP started looking at, how do we actually standardize this into something that everyone can use? And this effort was known as AHS, Adaptive HTTP Streaming. Started as in 3GPP, and then at the same time a similar effort started out in MPEG to basically do the same thing. And after some initial discussion, they basically realized, well, 3GPP has already made some progress in this. Let's essentially start from where 3GPP left off and continue on. And so those two efforts actually got merged into basically the same standardization effort. So now the 3GPP AHS spec is identical to what became the MPEG DASH spec. And so DASH stands for Dynamic Adaptive Streaming, or HTTP. The actual standardization process in MPEG took about 2 years, which if you've ever followed MPEG standardization, for anything really, 2 years is lightning speed. That's just incredibly fast for anything to actually get from start to finish in MPEG. There was a number of companies, there's about 50 companies involved in this effort. So Microsoft was involved, even Apple was involved, Netflix, Qualcomm, a bunch of companies. And there was also a lot of back and forth coordination with some of the other standards bodies and industry consortia, such as DEC, for example, 3GPP, HBBTV, and so on. So what ended up happening in the end is that MPEG Dash became this specification that rather than pick one method of doing adaptive streaming and saying this is the way to do it, really kind of ended up abstracting everything that made up smooth streaming, Adobe HDS, and Apple HLS. So really became this sort of unifying spec, a universal spec, rather than we're just going to pick one way to do the adaptive streaming and then push that through. So MPEG Dash was finally ratified in December of 2011, so that's now been just a little bit less than a year since then. And it's been published by ISO and IEC. And so there's actually 3 specs that came out of it. One is the MPEG Dash spec. And then the 2 other specs were there was an update to the ISO base media file format, and then there was the MPEG common encryption spec, which is very similar to the DEC common encryption spec. So this is actually just the first step in the process of sort of things that need to happen to get us all on the same page. Obviously, everyone's been promoting MPEG Dash very heavily. Some say, well, it's hype, but you got to promote things to actually catch some momentum. And the MPEG Dash ratification is really the first step in the process. The next step in the process is now agreeing on actual true interoperability, and that's what I'm going to talk about next. What is actually MPEG Dash, what it isn't, and what are the next steps to getting to a place where we're all actually talking to each other in the same language. So Dash is really the way to look at it. It's a framework standard. It's an enabler standard. It's a standard that says this is the framework within which we will all operate, but does not actually get down enough to the specific details to truly make it inoperable. The part that will make that happen is what's known as application profiles, and I'll talk about that in a second. So what Dash does specify is the actual media description. In smooth streaming context, we might refer to this as the manifest. In Dash, we refer to this as the media presentation description, or MPD. So this is the XML file that says, here is what this asset contains. Here are the bit rates. Here are the languages. Here's the different files it contains. And it describes everything you need to do to be able to retrieve and play back this particular asset. The other thing it specifies is the actual HTTP request and response syntax. So it says, here's how to request fragments, or maybe not even fragments, maybe the whole thing, and here's where you're going to get back. And it doesn't go into more detail than that. It doesn't say, well, here's how to decode it, or how, this is going to be H.264 or WebM or whatever. It just says, here's where how you requested, and here's where you get back. Now, the one exception to that is the actual file format. It does actually specify 2 file formats that are both MPEG file formats. One is MPEG-2 transport stream, and the other one is the ISO base media file format, better known as MPEG-4, which in this context we refer to as fragment and MP4 or FMP4. So those 2 file formats are specified by the MPEG Dash standard, but it also then provides explanations for how you can extend this to other file formats as well. So what does Dash not specify? It does not specify codecs. It does not specify resolutions or bit rates. It does not specify even the encoding recommendations, such as how long of fragments you should use, how often do you need to insert keyframes. Those things are actually not in the spec. It does not specify client heuristics. So what is the actual player behavior in terms of like ramping up and down the bit rates? How does it respond to network conditions? These things are not in the spec. The way this is addressed is through profiles. And profiles really, with any standard, especially MPEG standards, typically mean a set of restrictions that basically restrict, tell players what they can or cannot support. So in the case of Dash, we have first a basic set of profiles called Dash profiles. And there's a total of 5 or 6 of them, depending how you count, that only go down as far as saying this is the file format that we support, and this is the MPD syntax that we support. Then there's a next level of profiles called application profiles, and these restrict support even further by going down into more detail and saying, here are the codecs that this profile supports, here are the bit rate, not necessarily bit rates, but here are the resolutions, here are the DRM protections, and so on and so forth. So the true interoperability comes from the profiles, and specifically the application profiles. The basic Dash profiles that I mentioned, so as you can see, there's two columns here. They really primarily break down to which file format is supported. So on one hand, we have the ISO base media file format, or FMP4. And then on the other hand, we have MPEG-2 TS. For base media profile, there's a main profile, which then is split into either on-demand or live profile. And I'll talk about those in a little bit more detail in a second. And then for MPEG-2 TS, there's essentially just main profile and simple profile. Historically, the way these profiles came about is they actually map to certain existing technologies that were already in place before MPEG Dash came about. So for example, HLS maps very closely to the MPEG-2 TS main profile. Netflix adaptive streaming maps very closely to the ISO on-demand profile, and then smooth streaming and HDS map very closely to the ISO live profile. So as I mentioned before, the true interoperability really comes through the application profiles. After MPEG Dash was ratified, there was a group formed from a lot of the members of the Dash working group who wanted to go out and promote MPEG Dash, so it was called the MPEG Dash Promoters Group. And they grew very quickly, and after they grew to about 30 or 40 members, they realized, okay, this is no longer just a promoters group, this is an actual industry forum. And so the Dash Industry Forum, or Dash-IF, was formed at that point. It already has about, I think there's more than 60 companies in Dash-IF right now. And they have several goals, and one of those goals is achieving interoperability between basically everybody who supports Dash. And so they have an interoperability working group within Dash-IF, and this group is charged with coming up with something called Dash 264. And Dash 264 is an application profile that specifies the actual codecs that will be used for Dash, and also resolutions, DRMs supported, and so on. So for example, Dash 264, based on the name, you can figure out that it supports H.264 as its primary video codec, and then it supports AAC, supports DTS, Dolby Digital, MPEG audio codecs. So this is where we get into the real specifics. And this is, like I said, true interoperability will come from Dash 264, not necessarily from Dash itself, but Dash 264. Because at that point, I can guarantee that my player can play the content that your server is serving, because we're both compliant with the Dash 264 application profile. All right, so now that we kind of explained the history of it, how we came to Dash and what Dash is, let's talk about the actual act of caching and delivering content, which is really what affects CDNs. So cacheability is really directly related to the way fragments are addressed in Dash. And the actual addressing method depends on the profile that's being used. So I'm going to focus on the ISO profiles in this case, just for sort of sake of time. So ISO base media file on-demand profile uses something known as byte range seeking. And byte range seeking is really suitable for on-demand content primarily, because you pretty much need to have the entire file available already on the origin server, so that you can then make byte range requests to only particular parts of the file. And that's how it extracts its fragments. So the downside there is that the client has to know how the actual timeline in the video maps to byte ranges. And so that's the responsibility of the client to know, and then the client goes back to the server and says, okay, now give me a byte range for 326 bytes of the file to 472 bytes of the file. And the server can be a very dumb server. I mean, the cache can be a very dumb cache. It has to have absolutely no knowledge of the file underlying. It just does a byte copy operation at that point. So that's the advantage of that profile. Now there's something called the ISO base media live profile, and that uses indexes, so numbered indexes and timestamps to do the addressing. So the client only needs to be knowledgeable of like either which fragment it's requesting in a row. So maybe it'll say, I want the 10th fragment, it's the beginning of the file. Or maybe it'll say, I want the fragment that corresponds to the 22nd second of the file, for example. And that can be, the live profile, despite its name, can actually be used for both on-demand and live delivery. So if we take a closer look at the on-demand profile, that's really optimized for pre-delivery of on-demand content that's in high demand. So because the whole file needs to be available on the origin server, the cache, the edge, actually has a choice. Either you can ask for specific fragments all the time, or it can actually be intelligent about it and request entire file pages, then stores locally in its cache, in its edge cache, and then picks out the fragments from the file page that it cached, right? So what I'm talking about is that if you have, for example, let's say a 5 gigabyte file, 5 gigabyte, yeah, on the origin server, and there's a fragment request coming for just a 2-second fragment, rather than make, 1,000 requests for 2-second fragments, maybe you immediately copy the first 500 megabytes to the edge. And then those 2-second fragment requests can basically be drawn from that 500 megabyte file that's sitting on the edge, rather than going all the time back to the origin. So it's possible to really optimize the delivery experience. But again, this is really, if you're doing on-demand delivery, this is when it's optimal. And you can see an example, hopefully you can see it, it's a little bit dark, I suppose. But this is an example of what the requests might look like. So you might see the byte range request expressed at the end of the URL. And like I said, the responsibility then is on the client to know what those byte ranges actually map to in the video file, which they learn from the MPD. With the live profile, particularly like the one that's indexed, that's something that can be used for delivery of on-demand content. That's probably about like medium demand, I would say, and also live content as well. And here, all the fragments are indexed in terms of order. So rather than have a list of timestamps, you basically have a list of durations of each fragment, so that if you have a list of durations, and let's say that every fragment is actually the same length, then you don't even need a list of durations, you just need to know the number of fragments in the file. So if every fragment is 2 seconds long and you want to seek to 60 seconds into the file, you know that you need the 30th fragment in that case, right? And so based on that, for example, the URL might look something like this, where if you want the 34th fragment in a row, you just request the 34th fragment. Now, the actual syntax might change from server to server technology, but the underlying concept is going to be the same, that you're requesting something that's indexed. This also means that you can implement prefetching very easily. So think in terms of live scenarios, for example. Let's say that I'm doing very simple live streaming where I'm not basing it on any sort of time code, so I'm just starting from time code 0, essentially. And now I'm streaming my live video, and every fragment, for example, is 2 seconds long. If I have a client, for example, that requests the 34th, for example, fragment from the edge, the edge, of course, if it doesn't have that cached already, it's going to go back to the origin and ask for that fragment. But why not immediately then ask for 35th as well, right? That's very easy to implement. So this lends itself very easily to fragment prefetching. And then the other type of live profile is going to be the time-based live profile. And that's when, instead of, that's where you have timestamps in the index, in the manifest. And the advantage of this is that it allows, for example, variable fragment durations. So you can have anything from, half a second, or well, half a second. You can have anything from, 10 milliseconds to 20 seconds long fragments. Because all you're really indexing in the MPD itself is the timestamps for each fragment. It also allows multiple encoders. So let's say that you have one encoder doing the bit rates from 300 kilobytes to, let's say, 3 megabits, and then you have your second encoder encoding from 3 megabits to 6 megabits, and both are actually pushing those streams into the same ingest point. If they're time synced, if they basically are using the same clock generator, then you can actually have both of them completely perfectly synced, and that's what having a time-based manifest allows us. This is very similar to how live smooth streaming operates today. So if you're familiar with live smooth streaming and the way that's implemented, for example, in the CDN in terms of delivery, then this is going to be very similar as well. All right, so just briefly, I'm going to also talk about Dash and Windows Azure Media Services. So Windows Azure Media Services, and I mentioned this earlier today, this is our cloud platform as a service, where we're offering a lot of the on-premise services that we had before with IIS Media Services, Expression Encoder, PlayReady DRM. We're moving all those services into the cloud and offering them as a platform. So what this is going to enable you is to do things like ingest the media, encode it to other formats, such as smooth streaming, for example. If it's easily transmuxable media, such as maybe smooth streaming, we can actually transmux that into HLS or Dash without actually doing any sort of re-encoding. If you want to protect it on the fly with PlayReady DRM, we could do that too. And then, of course, we can serve that from origins that are in the cloud. We're also planning live services as well, so the ability to actually do live origins in the cloud as well, and analytics and ad insertion and so on and so forth. We don't have that enabled right now. So right now what we have is a preview of the on-demand services, and that's going to be going to market before the end of the year. We're going to have the on-demand services complete, and then next year we're going to work on live services. And then as far as CDN integration, we support both our own CDN, which is Azure CDN, is sort of the default CDN, but we also support partner CDNs. They can integrate with Azure origins as well. So if you're, let's say, an Akamai customer and you want to continue using Akamai, we're not going to force you to switch over to Azure CDN. You can keep using Akamai with the origins that are operating in Azure Media Services. So I mentioned already some of the features that we have. So by default, we're going to be supporting Expression Encoder in the cloud, which we now redubbed to Windows Azure Media Encoder. We're also going to support third-party encoders. So we already have Digital Rapids working on deploying their Kayak encoder to the cloud. We're also talking to Atem, a few other companies of deploying their own encoders to Azure Media Services. I mentioned format conversion earlier, so the ability to convert GOP-aligned MP4s into smooth streaming or smooth streaming into HLS without any re-encoding. And then encryption with PlayReady, DRM, and then of course smooth streaming delivery from our origins. So what's the Dash roadmap look like for our Windows Azure Media Services? Our priority is going to be implementing the Dash ISO live profile for several reasons. The first reason is because the ISO live profile looks like it's going to be the basis for DCE common streaming format, which is essentially based on the common file format according to the Dash 264 constraints. So that's pretty close to smooth streaming already, and so it's close enough that we feel most comfortable with supporting this first. And it also looks, from talking to a lot of the companies, that that's going to be probably the most popular of all the Dash profiles. So we're going to start with the Dash ISO live profile and then proceed then based on demand with other ones. The first thing we're going to light up is going to be conversion, really remuxing from GOP-aligned MP4s into Dash, specifically Dash 264. Then the second thing we're going to light up is something we're calling dynamic remuxing, and I'll explain that in a second. And then the final thing is the ability for our own encoder, Windows Azure Media Encoder, to actually spit out CSF Dash 264 compatible files. So the dynamic remuxing that I mentioned earlier, this is a feature that we're looking into developing. Basically, right now, if you want to convert, let's say, from smooth streaming to HLS, you have to do it as an offline conversion. So you end up with two sets of files. You end up with your HLS files, and you end up with your smooth streaming files. And then maybe if you're doing progressive download, you have your third set of MP4 files. And then, once we start supporting Dash, you might have your fourth set of files. And so obviously, that's very inefficient if really what's inside them is the same thing. So if what's inside them is the same H.264 elementary stream and the same AAC elementary stream, then there's no need to actually keep 4 different sets of files on the server. So what we want to do is keep just a single set of files on the server, preferably GOP-aligned MP4s, which that way are then also able to be delivered via progressive download, and then dynamically remux them to either smooth streaming HLS or Dash, depending on what the client is requesting. And we also want to have the ability to implement common encryption with AES encryption and play ready. I'm gonna skip this one. Basically, it's just about our client reach and how we currently have smooth streaming client SDKs delivering to a lot of different platforms, and we're gonna expand that with Dash support. And so what's next? So DEC standardization of adaptive streaming is something that's happening right now. Now, maybe you're going, oh my God, it's another standardization method of adaptive streaming. Why another one? Well, fortunately, it's actually based on the good work that we've done with MPEG DASH. And what it is, it's really just kind of restricting it down to something that's interoperable as well. So you can think of the common streaming format that DEC is developing as essentially common file format plus an MPD manifest. And what that equals is common streaming format. So, or another way to think about it is it's really Dash 264 applied with the common file format as its basis. There's other things that are being put into that standard, such as encoding requirements, packaging, file names, MIME types. There's a lot of information there, so really to truly make it interoperable as well. And because the ISO live profile is actually less restricted than both the Dash 264 and the common streaming format, both of those are going to be compatible with live profile. So live profile is really a superset of both of these. And one thing that's interesting about the DEC common streaming format is that it actually strictly enforces resolutions as well. So for example, it supports obviously 100% resolution, 75% resolution, and 50% resolution. So what that means is that if you're delivering a 720p file that's 1280 by 720, first you're going to deliver your 1280 by 720, and then the other encoded resolutions are going to be the 75% version of that, and then the 50% version of that. So that would be 640 by 360 would be your 50% version of that. So it's very specific about which resolutions it supports. And that's really to kind of make sure that set-top boxes can support it and that existing TVs can support it, so it doesn't go wild with resolutions. And that's something that, for example, Dash 264 doesn't enforce, but common streaming format will enforce. Then one thing that Tim mentioned earlier, HTML5, as you know, right now the video tag is not really very capable of much beyond doing progressive download. Because really none of the streaming stuff ended up in the HTML5 video spec. So that's being rectified right now in W3C. There's ongoing work to add both DRM protection and some form of adaptive streaming to the spec. The adaptive streaming approach that they're taking is really to enable something similar. If you've ever done Silverlight development, you might be familiar with the media stream source interface in Silverlight, which was really just an API that allowed you to kind of go and parse your own media and then hand off the H.264 and AAC over to Silverlight and say, okay, go decode and render this. So that allowed you to build plugins for smooth streaming, for HLS, for HDS, whatever you wanted in Silverlight. So W3C is taking currently a similar approach to HTML5, where they want to implement something like media stream source in HTML5 video that will allow you to basically go and parse Dash, for example, in JavaScript, and then pass those fragments over to the media stream source interface in HTML5. I'm not sure it's called media stream source interface. I'm just kind of using that word, but it might be called something else. But that's the concept they're taking. And then with DRM, they're looking at common encryption as, of course, being the basis for the DRM support in HTML5. So when is that actually going to be complete? I don't know. W3C tends to move, I think, a lot slower, actually, than even some other standards bodies. So if Dash standardization took 2 years, I'm sure W3C will probably take even longer than 2 years. So, I mean, unfortunately, it could be 2-3 years before we even see that standard ratified and then let alone deployed. So it could be quite a while. And so I don't know what's going to necessarily happen in the meantime. I mean, HTML5 was, to some degree, as far as video goes, was a bit of a red herring because everyone really got excited about it until they realized, of course, they really couldn't do much with it in terms of video. So I think in the meantime, really, we're going to have to continue dealing with multiple client platforms. So if you're delivering to iOS, you have to go build a native iOS app. If you are delivering to Android, a native Android app. Same for Windows Phone, same for Windows 8. I think that's just going to be the reality of the next 4 or 5 years until we really truly have an HTML5 standard that everybody supports. Because that's the other part of it, right? Because even if HTML5 video with all these new features gets standardized and ratified tomorrow, then there's still a question of, okay, which browser supports what? Is Chrome going to go and support like a WebM version of it instead of the Dash 264 version of it? Is Opera going to do something completely different? So there's still that open question, and unfortunately it's not something that really any company or any standards body can really go and enforce. So we're just going to have to sit back and wait what happens there. So the final thing I want to mention is the Dash Industry Forum. I mentioned it a little bit earlier. If you're a company that wants to be involved in promotion of Dash and early adoption of Dash, then you probably should join the Dash Industry Forum, because the interoperability discussion is really happening right now. The Dash 264 spec is being written right now. So that's something you can actually contribute to actively, and then make sure that if you really want to make sure everyone's talking the same language, you can actually contribute to that language being defined. So that's everything I have prepared for today, and so I'll open it up to questions now. Go ahead.
It's a question about live streaming. I've done quite a lot of work with chunks live streaming, and had some specific requirements a while ago about low latency for time-sensitive content. Now, the Apple standards basically say 20 seconds latency minimum, don't even think about it. And I did a lot of work with various platforms and got to about 6 to 8 seconds, but by using manifests with very few chunks defined in them, very short chunk length, and so lowering the quality of service of the stream and forcing no cache, fragment no cache on chunks and CDNs so that people can't get stale objects. Do you feel that the Dash specifications are going to lead us towards a better low latency solution?
It's possible. So we've done some work back with smooth streaming to get the low latency down to something that would really be considered low latency, so something like 1 or 2 seconds. And we were able to do that, but it was precisely what you mentioned. We had to essentially implement a way of requesting, even breaking down the GOP into smaller units. And so requesting keyframes or a series of frames rather than the entire GOP. So it's possible to get it down to about 1 to 2 seconds. And so if it was true for smooth streaming, then it's going to be true for Dash as well, because there's nothing in Dash that would prevent that from happening. The question is, of course, whether we're going to see encoders and servers supporting that, and then how soon. Because that's really what we ran into. I mean, we did develop this with smooth streaming, and then we kind of said, okay, here it is. And then I think we had one encoder vendor go and support it, and nobody else did. And we had maybe like 3 customers asking for it, and then there was just not enough demand for it to really kind of make it commoditized. So theoretically it's possible, but it requires server support and requires encoder support. And client support, I think, just kind of comes automatically, or maybe not. But it does require support from sort of all 3 input points. And so it's going to be a question of who's going to support it and how early. But is it possible? Yes. And the second answer to that is that I think we can only get it down to about 1 or 2 seconds at best. I don't think we can get it down to real time. I think that's just not possible with the way HTTP is architected.
So in the GOP model where you're requesting frames rather than a GOP, do you think that you end up defining that in your, I forget what your manifest, say this is the byte range for frame rate?
Yeah, you could define it in such a way where you essentially your fragments become really, really short rather than, so they become by ranges that might actually just be a few frames rather than an entire GOP. So it's possible to define that in the MPEG DASH spec. So it's just a question of implementation. Yeah, and there is an inherent quality loss to it as well, because it means that you have to basically inject keyframes more often than necessarily 2 seconds. So you might have to do it every 500 milliseconds or so, which then brings down the quality. It also means that you might not have as much of a buffer, video buffer in the encoder, which then means you don't have as much time to actually get the best rate control out of the encoder. So it brings down the quality as well. And then, so yeah, you have to reduce the latency in the encoder, you have to reduce the latency in the server, you have to reduce the latency in the CDN. There's a lot of fine tuning that needs to be done. So it's doable, it just requires a lot of work.
For the information, the MPEG industry, the MPEG committee is meeting right now in Shanghai.
It is, yes, yeah.
And the low latency is one of the topics they are going to discuss.
Yeah, so what I'm guessing is that they're probably going to come out with some sort of application profile recommendation that says if you want to do low latency, this is how you do it. Again, Dash is really kind of a framework standard that says here's the language you can use to define things, but defining things is a whole different set of steps. I'll take this one and
I
back.
think the stabilization, what you just described, will bring a different role of caching into the networks, especially now when the digital agenda 2020 network should be built more or less from scratch. And do you think the last mile networks will have different role in this CDN?
So, I mean, I think the way the standard was designed is to really make it compatible with existing cache infrastructures out there. So I think it's fair to say that most CDNs will just be able to work with Dash out of the box because it really, at the end of the day, is just HTTP caching. Now, there's things they can do to be more intelligent about it. So there's things like prefetching and, you know, copying entire pages, file pages to the edge ahead of time and things like that they can do to be more proactive. But I think every CDN that has just dumb web caches deployed to the edge doesn't really have to do a whole lot, if anything, to make them Dash compatible, because at the end of the day, it really just is HTTP requests going back and forth.
So you might get more transparent caches in the last mile networks as well. So out-of-band transparent caching is quite popular. I think with some networks trying to improve their last mile delivery for highly cacheable objects. But then this doesn't overcome any of the URL security mechanisms that the CDNs may put in place. And a lot of them are using header-based request response security now rather than a traditional token in the URL. So the transparent caching thing could really help, but especially with these kind of objects, because they're very small and they change.
Yeah.
But I think there are still some security issues that are going to stop them being able to.
A lot of the CDNs that today support things like smooth streaming and HLS do have sort of a special set of rules they use for media events versus other things. So there's features such as, for example, token authentication that they have special rules to know whether to apply token authentication only to the manifest, or what would be MPD, or to the fragments themselves, for example. And then they also have different paths. So, you know, if there's like a live streaming event going on that they know is going to be very high scale, then they don't want to necessarily, you know, have other traffic going through those caches besides the media. And so there's different rules that might get applied. So it's really, we're talking about optimization of the delivery path rather than going and deploying like new hardware and new software out there. There was a question in the back.
What do you see as the real value of Dash? Because from what you explained, it basically encapsulated all of the existing standards, and it's still going to be as fragmented as it is right now, maybe worse, because we'll have more profiles. Everybody will be branded as Dash, but it's going to be HLS, HDS, or smooth streaming. So what's the real value?
Yeah, I mean, there is a risk of fragmentation that exists even with Dash, and I think right now it looks fairly positive because more or less everyone's kind of seems to be in favor of having like a Dash 264 profile. But yes, there is a danger that somebody might say, I'm Dash compatible, but they're not Dash 264 compatible, and so they're not really interoperable. Really the only way to mitigate that is to make sure that the entire industry is talking to each other, and that more or less you have all the companies, you know, part of the MPEG industry forum, the Dash industry forum, and deciding about this together. And ultimately, if everyone's on board with something like Dash 264, then the companies that are not really don't have much options than to join, right? And you know, the big question that always gets asked is like, well, is Apple going to jump on board or not? And so that's the question that gets most commonly asked. And Apple's going to do what they decide to do, but if everybody else is using Dash 264 and it's only Apple really kind of pushing HLS, then best case scenario, Apple at some point decides, okay, we're going to abandon HLS and jump on the Dash bandwagon as well, because they were actually part of the writing of the standard. Or worst case scenario, we only end up with 2 delivery formats, which really at the end of the day is not that bad. So the worst case scenario is actually still quite good. Because today we're looking at delivering, 3, 4 different formats. If we can get that down to 2, that's already reduced cost by 50% to 100%, and that's not bad. Other questions? Go ahead.
Is there already existing layer framework for Windows 8 apps?
We are writing one. It's not available yet, but we are working on a Dash client SDK for Windows 8. It'd probably be, I would say, early next year. So we're looking at probably something like first quarter or first half of next year. I think we're either need to support the serving of Dash content ourselves first, or see enough servers deployed out there, third party, that we can then go and develop against, right? It's a bit of a chicken or the egg problem, because before you can really go and test this content, you need to have obviously servers supporting it first. So either we're going to wait until our server is ready with Dash functionality, or until there's another server out there that supports it, probably the Dash 264 profile. But I would say realistically it's going to be first quarter, first half of next year where we finally have a Dash client SDK come out for Windows 8.
After that, application developers have to implement them.
Until then, most likely, yes, yeah. Now, the way Windows 8 is architected is that if you have a third-party developed one, then you could reuse it, right? So you can develop like a media foundation media foundation source that then you can deploy with your Windows 8 application. And so if, let's say, like a third-party out there comes out with a Dash client plugin that's a media foundation source, you can then license it from them and use it in your application. So it doesn't necessarily have to be us, and that's also the thing to realize is that, whereas with smooth streaming, it was really kind of us pushing all the client SDKs, developing those. Now that it's an open standard, we don't have a problem with a third party saying, hey, we have the first Dash client for Windows 8, and we're going to say, awesome, go and sell it as much as you can. So it might be somebody else before it's us, but we're definitely going to try to develop our own. I'm sorry?
There's no one so far.
There's not one so far that I know about for Windows 8. I think he was first, actually. I'll come back to you.
Would you agree that with all HTTP-based streaming formats that you actually require a CDN for global streaming distribution, which was not the case actually with the so-called traditional streaming formats? And how many future adopters of that are actually aware of that fact? They not just can put out their own UDP-based streaming service and just do global distribution for small audiences.
So I agree with the first part of that statement, which is that you really truly do need a CDN to deliver on a global scale with adaptive streaming. I disagree with the part where you didn't need a CDN before with traditional streaming. I think it was necessary really for global events. And there was a whole number of events that have shown that, because there's been obviously global large-scale live streaming events that were attempted using Windows Media, using RTMP, and if they're just coming from origin servers and there's no CDN in between, it really doesn't go well.
For large scale, yes, for small scale.
Yeah, for small scale, yeah, it's not necessary, but I would argue that for small scale, you don't need really a CDN with adaptive streaming either.
Latency is the issue.
The latency is the issue, yeah, but that's not necessarily that big of a problem. I mean, so it's possible today to do something like a Ustream TV or live stream with adaptive streaming without using a CDN if you're just broadcasting to 10 people. I don't think that's a problem necessarily. But once you get above a certain number of audience, then you do need a CDN.
What's the maximum latency? What's the maximum latency are you talking about before you start seeing a detrimental effect?
What the minimum is before you start seeing, or? Yeah. It's hard to say. I would say if I were broadcasting without a CDN, I would probably try to have at least about 60 seconds of latency just to make sure that everyone's getting their fragments in time, just kind of based on experience. 60 seconds of latency from end to end.
Force you put the latency in there so the files can do it, as opposed to what is the buffering, 60 seconds buffering.
Yeah.
Well, start, yes. But
And also keep in mind that even if you don't have a CDN necessarily as part of your delivery solution, there's still caches that ISPs have, for example, along the way. So you do get a little bit of caching from your ISP and maybe some of the gateways along the way. So, but the CDN is the way to ensure that it does get as close as possible to the customer.
Andreas, I think it would depend where your audience is going to be. So if you have an audience that you knew was West Coast US and Paris, it's different from saying actually it's in 10 countries. So
I think the North America is not the problem either. It's Paris, it's the South Africa, it's Asia Pacific, it's Hong Kong, it's Australia. That is actually usually the traditional markets. You see problems in terms of quality of service in terms of stream delivery. In Australia, we are happy if we get 100K streams through, even with using CDNs, right? Or in South Africa, a 50K. Let's say, I mean, maybe slideshow is probably those things to go. That's always the problem for service providers. If you're talking North America, if you're talking Europe, 3, 4, 5, 10 megabits, not a problem at all. But that does not necessarily mean that is where all the audience is.
The other thing is if you don't have a CDN, and everyone's basically going back to the origin to fetch the fragments, the other thing you'll notice is that the average quality, video quality tends to go down because people now start taxing the origin server rather than the actual edge caches. Because really the biggest advantage we've seen from going to adaptive streaming delivery with CDNs is the quality go up. Because now everybody can actually, not everybody, but a lot of people can now sustain HD video at 3 megabits, 6 megabits, right? So either 720p or 1080p, which you really could not do with traditional streaming before, and you definitely couldn't do without a CDN if you were trying to get to, let's say, 10 or 20 people. Because if all those 10, 20 people are going back to your origin server and each one of them is requesting the 3 megabit stream, you're going to run into trouble very quickly, right? Because your network card at some point is going to be pretty loaded.
In the end, those effects combining, so you have clients who require low latency, so you reduce the latency. So the 60 buffer seconds isn't really the way to go in the first place. Then you have a global distribution, and that's the point where it gets challenging. So you say, I would like to have one streaming format, but then again, it starts being different per territory. And that's again where all those problems that currently start combining. It all looks good in the PowerPoint rule, right? And then when you're hitting reality, saying, okay, I wanted to have a single format, and I wanted to have a single distribution format, but suddenly, suddenly again the territories kick in, and you say, well, I need a low latency for the markets with high bandwidth, like North America, Europe. I need another format again for those South Africa, Hong Kong, and Australia, and then suddenly you have 2 formats again.
I don't know if we necessarily need 2 formats. You might need like 2 different sort of structures, right?
Streams, different gobs, different.
Well, I wouldn't even go that far. I still think you can do it with one single format. I think you might just need a different structure. Go ahead, Tim.
2 quick questions. Dash 264, okay, we're working on that. Dash 265.
So I know that Dash as it is HEVC ready. So they're definitely ready for HEVC now. I haven't heard about Dash 265 being developed yet, but because 265 is so early in its adoption stages, I'm guessing it's probably going to be another year or 2 before we see that.
Yeah, so maybe the question there is, it is open to the codec agnostic.
Oh, absolutely, yeah. It is codec agnostic, and it's definitely ready for HEVC. I mean, they made sure of that even like when they were defining the ISO-based media file type. So it's just a question of 265 getting enough momentum in the market, and then they're going to obviously.
That leads to the second question. I think of the Wi-Fi Alliance. When the original Wi-Fi logo came out, it was B.
Yeah.
And then G came along, N came along, so we have different logos. From a branding standpoint, is the IF actually looking at things like that, or is the Dash 264 so that we know that a product is compliant?
I don't know like whether they're going to go into specific I mean, I'm guessing there's going to be a Dash 264 certification process. I know they're working on things like releasing test vectors, for example, to make sure your content is compatible in tools and so on. Yeah, I mean, DC definitely like has its own branding with Ultraviolet. So I'm guessing like we'll see some high level branding, but I don't know like how low level it's going to go. But that's probably like a good question to ask directly of the folks who are in charge of Dash. If any more questions?
Alex, I had an interesting chat with a Cisco engineer who was
Yeah, I definitely agree it's a pragmatic solution. Like I was saying earlier, it's really a response to the way the internet is architected today, and like, you know, the state of things today rather than trying to, yeah, shape the internet. But you know, you can actually adopt a lot of the things that are part of Dash to even things like multicast. So at that point, it would no longer be, you know, over HTTP, obviously. But we've done things like live smooth streaming over multicast, for example, and that can be made to work.
Are you aware of any engagement with the IETF? I don't happen to be aware of any myself. I just wondered whether the IETF, because RTSP actually do have some IFCs, and so I'm just wondering if Dash is, and the IETF are talking.
Right, I'm not aware of it, but I'm yeah, I mean, since everything is kind of going in the direction of OTT, you know, dedicated multicast delivery might be a thing of the past for all we know. And I mean, a part of it is that maybe we're moving in the wrong direction by making everything HTTP, but it's certainly the way I think organically the industry is moving.
In terms of vendors, if you talk to Cisco or Riverbat or Silver Peak, all those kind of corporate appliances vendors, they are more than happy, because from them it's the leverage to start selling millions of appliances to corporations. So, okay, now we have the HTTP, we have the protocol of their appliances, done that, and the magic in between. Proprietary, obviously, but that's the reason why they sell their appliances. And from their point of view, they really like it that we start cramping all the corporate networks, because then they come in and say, oh, yeah, I mean, all the green, blue, yellow, whatever boxes, right? Just deploy them, and it's transparent for the client, the user. So it's still HTTP in, HTTP out. What happens in between is then actually, depending on the user, if it's multicast, unicast, deduplication, whatever they then actually do internally. Yeah. So for them, that actually starts being a multi-million, probably billion-dollar market in the end. Helping the enterprises again, they already did that 10 years ago. Blue Coat was going in there. Here we have the proxies which are Windows ready or Flash ready, and now it's again, oh, thank you very much. Now you have to rebuy all the appliances, rebuy all the intellectual property, because that's actually what it is, right?
Yeah, I think enterprises are probably the bigger issue, I think, than like versus IPTV, for example, because with enterprises, yeah, doing HTTP within an enterprise is actually kind of a problem, right? Because suddenly everyone's, it's a unicast, right? Method of delivery, so everyone's going back to the same server. There is a way, though, to, I think, architect a solution so that you have, for example, an origin that's sitting outside of an enterprise that's delivering via HTTP to the enterprise, and then that's being fanned out using multicast to the actual clients within the enterprise. So I think that could be easily architected.
But it's not about it easy. It's those vendors are seeing dollar signs saying, oh, great, we
yeah.
have it 90% there, but we can resell it again to the clients, because it's not, they have spent millions on the Microsoft streaming licenses, millions on the Flash streaming license. Now, well, HTTP, new format, great, new protocol. Let's charge them again. I think that is exactly the point where the enterprises of Scrooge have built over the last 10 years, Windows Media and Flash, and that's the reason why they're so focused on trying to find vendors and still finding CDNs who do traditional streaming formats, because the turnaround takes 5 to 10 years, but usually first of all an enterprise needs to see an adoption. They're not going to buy devices or licenses because someone's saying, well, I think Dash is the future.
Yeah. Dash is definitely something that was designed for delivery over the internet. I mean, specifically the internet. So, you know, a very large TCP-based network. And the difference between the older traditional streaming is that those were kind of like, let's design it in a box, let's design it in a bubble.
The problem is the Olympics, right? So many corporate networks,
yep.
Administrators, firewalls have just started swearing the very moment we have the 100-meter finals or even World Championship, employees using just tickers. It's not necessarily video. It's already people just getting sports tickets
yeah.
at their desktop.
Yeah. But there's a lot of potential for companies to come up with solutions there. Yeah. To say, okay, how do we fan out this traffic within the enterprise, even though it's coming in as HTTP?
Interesting. That's the first mention of the Olympics.